And welcome to tonight's EngTalk, inspired by the life and work of Sir Frederick Henry Royce, one of the finest mechanical engineers in UK history. With an engineering philosophy of pursuing excellence, Royce is famed for his work creating groundbreaking engines used to power iconic cars and aeroplanes. The son of a miller, Royce became an apprentice engineer at the tender age of 15, and by the age of 19, he was chief electrical engineer for Liverpool's first electric street lighting system. In the early 1900s, he started designing and building experimental cars, one of which caught the attention of a certain Charles Rolls. The rest, as they say, is history. Ladies and gentlemen, also in the pursuit of excellence, please welcome your host for this evening, Steve Fowler.
Good evening, everyone. Thank you very much for coming along this evening. Welcome to the EngTalk this evening at the IET. It's delighted to be here. You probably don't know me. I'm a fish out of water. I'm a journalist. Please don't boo just yet. I don't work for the Daily Mail. I actually run a number of car titles, which is particularly pertinent to today's speaker. I edit Auto Express, Car Buyer, and a new website we've just launched called Driving Electric. Again, quite important in today's world, and something that our speaker today will talk about. So why am I here amongst all these engineers? Well, I like to think journalists are a little bit like engineers. We're problem solvers. We like to make things easier for people, particularly in my world, where it's my job to help people choose the right car for them, the next car they're going to buy. They're going to be spending a lot of money. So I get a wonderful helicopter view. I'm very privileged to see over the entire motor industry. And I get to see a lot of engineers. For me and for our readers, engineers are the Hollywood stars of the car industry. None more so than tonight's speaker. Hang on, yes, that is the money that he paid me just going into my bank account. But in all seriousness, the guy you're going to hear from in a little while and his team do some fantastic work. How good is the work they do? Well, let's just look at some of the cars that we've given our ultimate accolade to over the past couple of years. 2017 Auto Express Car of the Year was the Land Rover Discovery. 2018 Auto Express Car of the Year, the Jaguar I-Pace, a real groundbreaking car. I first met Nick many years ago and got to know him really during, I think it's called 405, what do we call the Range Rover these days? And being honest, from my point of view, I'm not allowed to have favourites. I have to be completely unbiased, but if I was going to spend my own money on a car, having won the lottery, obviously, it would probably be a Range Rover. Could well be an I-Pace today. The cars that he's creating really are that good. So it's a deep honour for me to introduce you to the Executive Director of Product Engineering for Jaguar Land Rover, Mr. Nick Rogers.
Good evening. Come on. You can do better than that. I'm just a shy engineer. You've got to help me. Good evening. Good evening. It's an honour to be here tonight. It really is, and really appreciate you making the time. And I'll do my best to share some of the passion that I've got for engineering here in the UK. The key subject really is, as an engineer, you've got to look at what you're doing every single day. The truth is, technology and innovation moves on every single day. Time waits for nobody. So the reality is, you are either disruptive, and the engineer's obsession is to do whatever they've done to find a way to do it better. Engineers are always very critical. They have a be perfect driver. So you either keep on disrupting, keep on driving innovation, or you simply are disrupted. So we're really passionate about making sure that we actually do disrupt. Everybody talks about ACEs, autonomous, connected and electrified. It will propel and change the automotive industry. I've been lucky enough, I don't think Steve said I looked old enough, but I've worked in Jaguar Landrover. I'm in my 35th year. Oh, wow, okay, right. That was a response, wasn't it? So that's half the life of the company. So I've seen incredible change. I used to, 5 years ago, tell everybody that in the next 10 years, you'll see more change than I saw in the last 30. I would promise you the last 5 years have been absolutely amazing. some of the things that have happened, the change in technology, the passion for many things, but making life better for individuals is a thirst that never ever stops. And I will talk about some of that, but let's reflect on a few things. What have all these things got in common? What firsts were they? So, 1902, the smoke detector was developed. Very, very simple smoke detector, just developed heat. That then was formalised going forward and more sophisticated smoke detectors were created. And the simple fact is that if you have a smoke detector in your house, you're 56% more likely to survive a fire than if you don't. Think how many thousands of lives, think how that has made lives better by a simple thing of a smoke detector. Also think, unfortunately, thousands of people still die every year because they haven't got a simple smoke detector. Other simple technologies here in the UK, bimetallic strip was added into a kettle, which means that suddenly kettles weren't boiling dry, houses weren't burning down, and a huge safety leap was forwarded by Mr. Hobbs. He made friends, and Russell Hobbs became a brand, as you know. In 1962, medical science. That is a real key thing that engineers drive and work with people in medical science. The first hip replacement was made. I don't remember 1962, I'm not quite that old, but imagine things back in 1962. They were cutting people's legs apart, dislocating the hip, cutting the end off, putting a metal hip in and replacing it. Now there's thousands of people a year have a new hip, absolutely changing their lives. That's engineers delivering that. The defibrillator was originally invented in 1930. Obviously it was a key tool that they used in hospitals to resuscitate people. But it was in 1965, the real innovation was that they noticed that really in the few minutes after a heart attack, within the first few minutes, it's roughly 10% less likely, if you're not resuscitated, that you won't live or you have significant brain damage, even if you do. So someone had the foresight to realise and focus that if you put a defibrillator in the ambulance, seems like an obvious thing to do, but it's an innovation, run the power off the battery of the ambulance, you could actually resuscitate people on the way to the hospital rather than waiting till they were there and they'd unfortunately passed away. 1967, cash machines. Incredible. You can't imagine life without a cash machine now, but back in 1967 it was created. Material was added to the little check that you actually put in. There was no card readers and all those things. Fantastic and change, and you could draw out any sum of money you wanted as long as it was £10. Yeah, so complete flexibility really, really changed people's lives. But the thought is that the material that was on those cards was slightly radioactive. So we've got to think about, when engineers create things, think about the consequences properly. Yeah, but that created a revolution and really, really did change things. The flexibility of being able to get money 24/7. Lithium-ion batteries, created here in the UK in 1980, was an absolute revolution. And can you imagine all the electrical devices now without lithium-ion batteries? Just, you cannot imagine it. Wasn't actually industrialised in the UK, though, was it? Would be the thought. We have fantastic ideas, but we don't always industrialise it. Talk about that a little bit more in a minute. And the World Wide Web was created here in the UK, a protocol for basically transmitting data, and it was part of the data revolution where it can actually communicate and share data. All those things here in the UK, what have they all got in common? They made people's lives better. Yeah? As an engineer, it's your duty to make people's lives better. That's the focus, that's the obsession. What can be better than making someone's life better? If you then look, Jaguar Landrover, I have the honour of working for many years with Jaguar Landrover. Some of the first that I really get excited about, there's very, very many, but just a few. If you look, the disc brakes. The technology was actually there on aircraft, and it was a way of basically shedding more energy as the aeroplane came in, so the runways could be smaller, you could get shorter landings. We introduced that in 1953 to win Le Mans. We were instantly wiping the floor. Real innovation technology was then developed and became a key safety feature on every car that you now sell. If any of you have ever stopped or tried to stop in a car with drum brakes, the key thing that you notice is you don't really. Yeah? And disc brakes meant that you could get an incredible amount of energy incredibly efficiently and slow the car down really efficiently. Then later, key one, 1990, ABS brakes. Can't even really remember driving cars without anti-lock braking now, can you? Years ago, if you were in a situation you had to take an adverse manoeuvre and put high level of braking in, the chances are most accidents, people locked the wheels up, lost control, huge accidents, huge fatalities. This was a massive change to safety, really did change everybody's lives. And suddenly, even the worst drivers could stop as quickly as some of the best. And it was foolproof if you weren't concentrating. 1997, really excited that we created the world's first full monocoque steel structure of the new Freelander. Fantastic vehicle. We took the opportunity to save weight and out of the vehicle, make it lighter, and we eliminated one of the things that Land Rover's always been renowned for, which is the low ratio box. Every Land Rover had always created had been able to go anywhere, both uphill, downhill, and pull anything in any direction, had this low ratio box. So if you wanted to go down a steep slope, you just put it into first gear, took your hands off everything, and it just crawled down very, very slowly. And the gearing back through the engine and the driveline meant you could do it. The engineers created a technology. We had a switch and a lever, and the ABS system did it. 2006. I think this is a key point because the emphasis here wasn't just on the occupants. Yeah? A lot of the safety revolution that took place through the 90s was in automotive, was focused on occupant safety cells, getting the safety cell, offset barriers, all of those things, pole tests, all of that, which is absolutely normal now. You couldn't imagine having a car without it. But this is, I think, a key change because we were focusing then on other road users. That responsibility of, I'm safe in my car, but is everybody else safe? If I inadvertently clip somebody, when you hit them, the most common thing is as the car hits your leg, you go over, head hits something very hard on the bonnet. Unfortunately, the brain doesn't like high G or the skull, and fatalities are huge. We created, using pyrotechnics, the bonnet actually popped up. So your head actually ended up hitting something much softer. So you got a much bigger time for the deceleration, therefore the deceleration is lower. The peak forces are lower, therefore pedestrians were surviving. That was a key change of that responsibility, thinking about others. 1999, the active radar, so a radar on the front of the car. I actually can't imagine now driving a car without a radar of cruise control. You can drive hundreds of miles effortlessly, you lock the car in front, you pick a maximum speed, and it just keeps a safe distance. If you lose concentration for a moment, you can rely on the fact that the radar and the computer driving it will not. Incredible safety aid. 2013, Steve mentioned it, the new Range Rover, first aluminium monocoque. Why were we obsessed about that? Simply, cars that are lighter need less energy to accelerate and decelerate. It was fantastic that we managed to get the 6-cylinder engine to have the same performance as the previous V8 cylinder engine in the previous derivatives. So effectively you downsized, huge step forward in fuel economy. It also had a hybrid system where an electric motor that every time you decelerated, scooped electricity up, put it into a battery. When you wanted to accelerate, you press the accelerator and it discharged the battery, used the electric motor to propel the car. So you got a better performance out of the engine. Again, recuperating all of the energy. And then this year, we're really excited that we've launched the new Jaguar I-Pace, the world's first battery electric vehicle, premium SUV. And we've had some fantastic awards and accolades, but there's numerous patents that's been created here in the UK that every engineer involved in that should be really proud of. So looking back and thinking of pioneering spirit, I work for Jaguar Landrover, 2 examples that really excite me of the past. Not sitting in the past, not dwelling in the past, but thinking about what these guys did. Imagine yourself, 1946, the war's ended, everything's rationed, petrol, steel, everything's rationed, lots of food still. And the Wilks brothers were sat there in the Rover Car Company, and they had enough passion to create a vehicle in a segment that they'd never done before, create the Land Rover, which they messed around with in their farm, and actually created a vehicle which was one of the vehicles that conquered and explored so much of the earth. They created it using aluminium because there was a plentiful supply. The UK put a huge investment during the war in aluminium production. The product that was used for that was not needed so much when the war ended. Aeroplanes. Okay, the humour isn't good here, is it? So they utilised that supply that was plentiful instead of using steel, and they made an aluminium body. They riveted it together, just like an aeroplane. And most of those vehicles were exported and brought money back into the UK. They were only going to make it for 2 years. It was such a success, and exports were absolutely stunning. Think of the jobs, the livelihoods, how many people that put food on the table, that put their children through school, by creating a product that when you look at it, try and find something that doesn't have a purpose. And then you've got Sir William Lyons in Coventry as well, just round the corner in the Midlands. He had created this XK engine. Beautiful thing. If you've seen the XK engine, straight six, it is beautiful. I like things anyway. And incredible engine. He got this engine and he had the foresight, let's create a sports car that does 120 miles an hour. Imagine sat there 46, 47, creating a sports car to do 120 miles an hour. But the foresight was incredible. Customers wanted it. And the customers were generally outside the UK, brought huge wealth back. Clark Gable had one of the first ones. It was an incredible hit, instantly sold out. Couldn't keep up production, had to retool it and create the supply. That is the passion to do the unthinkable. And that's what engineers have got to think about. And there's nothing more exciting than being told you can't do that and finding a way. Engineers in the room agree? Yeah, slightly more confident. Engineers in the room agree? Yeah. Cool. So, in Jaguar Landrover here in the UK, the scope of technologies in an autonomous and connected and electrified and shared world that we're exploring now is absolutely incredible. The breadth of things that you look at, the breadth of the research, the breadth of the R&D is fantastic to be part with. It's a real honour. The amount of engineers focusing on new technologies, solving problems that people didn't know they had, is just an honour to be part of. And every engineer should be really excited to be part of that, no matter what industry you work in. So the challenge, and really the focus of what I wanted to talk about tonight, is if you look at the automotive sector, it's full of distractions. When you drive a car, one of the biggest challenges is the amount of distractions. It's absolutely fantastic that everybody's got a mobile phone these days, isn't it? It's absolutely fantastic. You can work 24/7. You can be got hold of no matter where you are in the globe. You're always connected. Yeah, your kids can be on it all night long. It's awesome, isn't it? Truth is, you can't stop progress. And that technology comes. Unfortunately, people use that in the car. We've got to think about that, and we've got to think about these distractions. Emissions, health, pollution. We've really got to worry about that. It's a televised sunrise because it's so polluted. We've got to really think about that. Engineers have got to solve that problem. Engineers have created that problem. Then think, how much time do you spend sat in a car? It's not good, is it? You could use the time better. How can we streamline that? And then, in a shared world, we've got to embrace the fact that cars could be shared by others, and you get more efficiency out of them. Those are all problems to be embraced. They're challenges, and they're a positive thing, and I'll talk a little bit more about them. So, the vision and the challenge I put out to the engineers in the room, because there's nothing more motivational for an engineer to put something right out there that everyone goes, can't do that. And we've got that spirit in the UK that somehow we do think of the impossible. Look at those inventions that you've just seen. So the challenge that we're putting out there is imagine a world with zero pollution. Got to dream of that, haven't you? That has got to be the vision for every engineer to be obsessed about. It's pretty way out there, I'll accept it. But that's what engineers have got to think about. Zero accidents. Got to focus on how do you get to zero accidents. Every 25 seconds, someone dies in the globe somewhere in some sort of transportational accident. Incredible, isn't it? Almost over 2 a minute. And zero congestion. Urbanisation is coming. There's about 30 megacities at the minute. There'll be 42 within 10, 15 years. That's what all the data says. How do you take that as an opportunity? How do we eliminate that congestion? How do we get more throughput from the roads networks that we have? It's an engineer's duty. So let's talk about cleaner. So ACE is the phrase: autonomous, connected, electrified, and shared. Autonomous. Everybody talks about autonomous. Some they'd say they love it, some say they hate it. The truth is, driver aids are going to help safety. So they are going to come, and engineers have got to find a way of doing it. They've got to work with the lawyers as well, but they've got to find a way of doing it, and driver aids are going to become more and more relevant. Connected. You can't change what's happened. People want to be connected every moment of the day. You know, the thought I would give if I take a car home, lucky enough to drive test cars regularly, when I take it home, first thing my daughter asks is, what's the Wi-Fi hotspot, Dad? Yeah, you're there in a really cool car as the old guy. What's the Wi-Fi hotspot? You can't change it. It's coming, so engineers have to embrace it. And electrification and efficient propulsion systems, absolutely coming. But the last challenge is probably a real challenge for engineers. Engineers, sorry to break it to you, the ones in the room, don't tend to be the most sociable. Yeah, I don't know, some of you, whether you've realised that. You know, we occasionally get accused of being a little bit nerdy, a little bit insular. Sorry to be rude, but it's true. Yeah, generally that's true. Yeah, not always. So adopting a shared economy is a real challenge. Look at the software industry. Look how much better it is when you have shared software, open source software. That's not quite like how engineers like it, is it? Because they like to do their own little thing and they show that they've done better than somebody else. As engineers and as engineering leaders, we've got to teach people to share. It's a real challenge. But the benefits for total society are absolutely huge. So cleaner. Pollution is horrendous. I'm sure you've all seen the things on the television about pollution in our seas and plastics. Engineers have caused that. We've all caused that. We've made that happen. It's our duty to focus on resolving it. Emissions and air. The truth is, all of the industry is pumping out emissions, and the truth is 9 out of 10 people do not enjoy what would be classed as quality air for all day, every day. That is amazing, isn't it? Only 1 in 10 is guaranteed of that if you look at the statistics and the sources that we have. Absolutely terrible. What can be more important than clean water, clean air? It's an engineer's duty to resolve that. So, what sort of things are we doing? What sort of things are we doing to really focus on that? What are we doing to innovate? The Jaguar I-Pace. We're really excited about the world's first battery electric SUV. The engineers did some really cool things. They were obsessed about maximising the amount of energy you could store in a battery pack. Batteries are incredibly heavy. The energy is incredibly volatile, so you have to make sure it's in a controlled, very safe place. You can see there we've got 90 kilowatt hours of energy stored in the new I-Pace, right underneath the floor, so the mass is very low. And we focused an incredible amount of detail in making sure that the 432 lithium-ion, cool technology that was created here in the UK, unfortunately, there's very few battery factories here in the UK. We absolutely need to focus on that, need to drive that technology. But we got 432 pouch cells, because that was the optimum technology at this point that we focused on. 432 of them in 36 modules, all banked together with an incredible cooling system, because the batteries are like the human body. You all know about batteries, you know all about controlling temperature if they get too hot as the energy is being put in and put out. You've got to keep them very precise temperature. So we're absolutely obsessed about the cooling system and making sure we can get to every corner of every single one of those pouch cells. And we stored 90 kilowatts of energy. So we got a battery system that can pull 320 kilowatts peak. That's an incredible amount of energy, isn't it? Awesome when you think of how much is actually coming out on a peak. But then the sole purpose of that is to drive the electric machines. We put 2 electric machines, both front and rear, so it's 4-wheel drive. But the technology in that motor, we could have used an induction machine, but the engineers took on the challenge that if you use a permanent magnet machine, you can actually get the torque much quicker. You know that induction machines need to apply a DC torque to get it moving, to get up to peak torque. So we chose a synchronous machine. But then the basis of any electric motor is cutting flux. To get the maximum amount of turnings, we actually got a whole lot of patents on the design. And they're actually hairpin turnings that are actually square in shape. So they obviously tessellate and package far more efficiently. Square things tend to fit together better than round things. So we packaged an incredibly efficient motor. But the other key bit is, because we've engineered it very efficiently, the inrush current is about 80% less. So the initial current pulse that you get is far less than the induction machine, which means we were obsessed about making sure the performance of the Jaguar I-Pace was the same performance again and again and again. And we certainly wouldn't dream of having the car having a rolling start, to quote some of the 0 to 60s. This is a genuine vehicle that will give the customer absolutely the performance we wrote down for years of its life, and so will the battery pack. But all that technology was created by engineers here in the UK. Unfortunately not manufactured here in the UK, the electric motor, but we'll talk about that a little bit more in just a moment. Other key parts then. So the really cool thing about a battery electric car, and I think it really is cool, yeah? Any of you show your excitement at any moment. It is allowed, yeah? A little bit of humour. I know engineers are a bit shy, we discussed that. So the key thing about an electric car that is so cool is that the electric motor can run in reverse as a generator. And it means there's the real opportunity, and we discussed it passionately in the early days of creating this car. Wouldn't it be cool if basically every normal, reasonable braking event, the friction brakes were never used? We calculated and we worked out, took a lot of data, did a lot of testing, and found out if you get to about 0.4 G, you actually get rid of well over 95% of braking events. And you don't need then, if you can do that with electric machines, you don't actually need the friction brakes. Now, for safety situations, of course you use the friction brakes, but we created a system that can pull 0.4 G. We thought that was really cool. Goes around all of the test cycles, UK, Europe, and Asian, US test cycles without the friction brakes adopting. That means every time you decelerate, you scoop the energy up. It means you don't get any brake dust. It's really, really cool. But the other thing that we thought was really cool is, how about then, when you actually go into high braking events, when you drive passionately and spiritedly, journalists often do, often do, and it's quite fun, and it is a Jaguar as well, yeah, and we test it around the Nürburgring and all those sorts of things. We said, just to make it a little bit harder, because a few people said, you won't be able to do that, we made sure that you always pull 0.4 G, and then the friction brakes go over the top. So when you go into those really high braking events, as you tip in, you pull up to 0.4 G, that stays at 0.4 G, and then the friction brakes coming over the top. And what we thought would be really cool is if you couldn't feel it. And you can't. It is awesome. Really, really is cool. The braking engineers that created that, they are so excited. You should see them showing it off. It really, really is cool. But it's scooping up energy. And it was a problem that we thought they couldn't solve. That's what engineers do. Then think about battery electric cars. What's the key factor? Convenience of charging. Yeah? Cell technology, there's some pioneering stuff, and we're really excited about what we've got in the I-Pace. The biggest challenge is taking on huge amounts of electricity very, very fast. Really is a real challenge. On the Jaguar I-Pace, because of the cooling system that we put in the battery pack, because you can cool the excess heat out of pushing all that electricity, realigning all those ions in the battery pack, we can actually get 70 kilowatts of energy in 40 minutes. It's nearly 2 kilowatts a minute, or 1.75 for those engineers. 1.75 kilowatts every single minute. So if you do the maths, that's about 20 odd litres of water, equivalent of from room temperature to boiling every single minute. That's how much energy we're putting in. And we're obsessed about it because we wanted to have convenience. So you stop normally at the petrol station, but you're now stopping at the charging point. 40 minutes is about enough time. Send the kids into the toilet, get a coffee, find the kids, and get back in the car. Yeah? That's convenience, isn't it? Yeah? Or sit quietly and have a coffee and maybe a currant bun. Yeah? So that is convenience. You're not frightened to go. And that was an absolute obsession. And the engineers were like, bring it on, let's do it. We then had to make sure that the new Jaguar I-Pace shared all of the technology, reused all the technology. That's one of the key things with engineers, is recognizing that the value of IP is evolved and grows, yeah? Teaching these engineers to give and to grow. We actually focus on all the technology we got, the aluminium structures that we pioneered originally on XJ, then on Range Rover Sport, and other vehicles going forward, because the simple obsession was an internal combustion engine, if the car's lighter, you need less energy to accelerate and decelerate. Simple maths. So aluminium is significantly lighter. It's a huge challenge to put together, but we've got a load of patents that we created here in the UK. We actually riveted together. There's self-piercing rivets that go through 2-3 gauges of up to 3 millimeters that force those rivets through. Don't have a hole, because that would be too hard to manufacture in a line. It's actually self-piercing rivets that go straight through, push them through, about 100 kilonewtons. Robots just clicking them all together. A few thousand of them on everybody. Awesome to watch. We also recognise, though, it wasn't just a pure obsession for aluminium everywhere for the sake of it. If you look at the B pillar, for example, huge challenges for roof crush. Yeah, got to make sure if the car rolls over, heaven forbid, if the car rolls over upside down, huge forces. The B post, we chose boron steel, high strength steel, which is a hot stamp steel, basically, because it's not very ductile. So you get it very hot, put it in the press when it's hot, quite exciting to watch. It's really good fun. Yeah, and we riveted that into the car as well, and that's what the B post. So we used all the technology we created, which made the car significantly lighter. Why? On a battery electric vehicle, you don't use any fuel. Of course you do, use electricity. And you need less batteries, so you get a better range. So taking weight out is really, really important. It's all about making the car more convenient and better to use, but reusing all of that technology. Then also, engineers are just as passionate about internal combustion engines. Internal combustion engines are actually incredibly convenient. If you think about it, you have a little vessel in the car, holds 50, 60 litres gasoline, diesel, maybe 70 in some of the bigger ones. You can refuel it in seconds, very, very easily, very, very safe. And with the latest technologies of diesels, it's an absolute myth that the emissions are incredibly damaging. They are not. The emissions of the latest diesels this year, if you take the difference from 2000, which was EU5, to where we are now, the NOx reduction is gone from about 2,000 in 2010 milligrams per kilometre to less than 100 today in all of the cars that we've certified at every temperature usage as well. So the real WLTP testing isn't just at one certain temperature. Won't mention any German brands. I recognise that one. That cars now, they operate at every temperature, and we test them at every temperature. We're actually the only OEM that is actually certified and got through all of the testing robustly for every single engine configuration we have. We're pretty proud of that. The proudest moment was actually reading that in a German magazine, but engineers are competitive, by the way, which is cool. You should celebrate that, and you should harness it, and you should use it. Mustn't let it be destructive. So the exhaust systems that we have, why are they so different? Simply because there's a filter right at the front of the system, a lean NOx trap, which is basically like a little ceramic sponge. And the ceramic sponge at lower temperatures, because obviously when a car starts, one of the biggest risks to emissions is actually when it's starting up and warming up and getting up to temperature. And a lot of drive cycles don't get up to temperature very, very quickly. Goes into this filter, all the NOx is trapped in there, and it's only released when it gets up to about 200 degrees C. So when it's 200 degrees C, it starts to be released into the rest of the system. The gases then coming out of the engine go straight into a diesel particulate filter, DPF as we always call it. And again, those particles are trapped in there as well. But then the rest of the gases go through, and as the system warms up, and as the cat at the end of the system gets up to operating temperature, which is about 180 degrees C, note 20 degrees C less than when the NOx are let out, key thing, we thought about that, and made sure that when you inject urea through a very, very controlled system, you end up with lots of urea, lots of oxygen, and you basically get water and nitrogen back out the other end. And that's how we deliver the incredible reduction in NOx that we've got. A fact is that if every single diesel car was replaced with a new clean diesel car, the pollution would be absolutely minimal. It wouldn't be the cars that would be the issue. It's just a simple scientific fact if you do the maths. 2,000 down to 100, if every single car on the road was only at 100, the NOx would be an order of magnitude less and would be a much lower value in every city that we're in. So we should be absolutely pushing to do that. And there's a real future for this because it's a very, very convenient and efficient system. And there's the infrastructure to do it. Diesels also have a much lower CO2 as well. If you go back to gasolines, obviously you get higher CO2. So the engineers are also obsessed about what other technologies in the internal combustion engine. When turbos were first developed a few years ago, it was an absolute revolution. The turbo lag became a bit of a thing as well that you always talked about. Yeah, on the early diesels, when you only had a single turbo, you'd press the throttle, wait for something, then suddenly, whoo, you were off. Yeah. We developed twin turbo systems, which meant you have one turbo at low speed, one turbo at high speed to minimise that. And the latest diesels are incredibly torquey. Same with the gasoline or the petrol engines. Electrification, the engineers are creating effectively an electric turbo, which means that you can infinitely control how much extra air you want to push into the combustion system, how you can make the volumetric efficiency better, how you can make the burn more efficient. That's the key obsession that you have to have. And you can do that in an infinite control, far more efficient, and you only use electricity to push the air in, because obviously the turbo uses energy. No energy is for free in the system. And we will soon be introducing those technologies. Variable valves. We've got electronic variable valves. Every single valve on the inlet individually can be adjusted to absolutely tune how much air you want to get in and manage how much air with fuel. Basically optimize getting to lambda 1 is obviously the key focus for emissions. So that's key technology being developed here because we develop and manufacture. We've got the whole process chain of technology here in the UK. In fact, an important thing is that the ecosystem of engineers that we've got here in the UK is living in an oil-driven world. The truth is, it's predominantly an oil-driven world. It's an oil-driven economy. And we've got infrastructure, R&D, engineers, but also manufacturing. There's lots and lots of technical skills in manufacturing that are driven with this technology. We've got to make sure in the UK that the engineers, as that technology changes, we make sure that full industrial footprint or process chain is here. Because engineers' jobs is to create innovation, but also to redistribute wealth. Yeah? Engineers make things, they create innovations, they sell things that people want, and it brings life, brings money back in, gives people jobs, puts food on the table, sends children to university. We also put in particulate filters on gasoline as well. Much smaller particles and less particles on gasoline engines, as you know, but we're adding that as well to really make sure that we minimise that. So, zero pollution. Engineers are obsessed about it, but we have to keep on going. Safer. You have to care about accidents. You have to care about it. It's no good looking at statistics and say 20% people, you're 20% less likely to die in a car crash, or you're 20% less likely to die somewhere. It's very hard telling that to the ones that unfortunately did, or obviously their families. That is a real challenge to do that. So we've got to be obsessed with it, and it's a duty as an engineer to think about that. Distractions. I mentioned the mobile phone. You are supposed not to use your mobile phone in the car. However, unfortunately it happens. There are many other distractions that take place in the car. If you drive through a city, you're significantly more distracted. If there are things going on that are more distracted. Perhaps a thought to bring it to life. Family holidays when you're a kid. Got the opportunity to go away in the car. Mum and dad or your guardians in the front of the car, uncle and auntie, whoever it was, the older people in the front. Yeah, one driving, one navigating, you sat in the back. What always happens at a certain point in the journey, you get lost, don't you? It seems to happen like a ritual, yeah? And it usually happens when you get near a bit you don't understand. It may be dark, may be raining, might be in a city. Tensions get up a bit. And what happens is that the driver is actually suffering with the amount of cognitive load. And they turn around and shout, if you don't shut up, I'm going to have an accident. And you sat there as a kid thinking, what am I to do with that? Yeah, what have I done? Yeah, what's it with you, dad or mum or whoever it is that's in the front? The truth is you're distracting them. So that's a thought. How often when you're doing a difficult parking manoeuvre, do you turn the stereo down? You do it, don't you? It's all part of cognitive load. So we've got to think about distractions. Engineers have got to solve that problem because whether you like it or not, the distractions are going to come. And that's a key part of making life safer. So we're doing a lot of research looking at the human brain, yeah? You guys are mostly engineers. You know the human brain is basically a big computer, yeah? It's a big processor, but it's only got so much processing power. Some have more than others, don't they? But it's actually only got the same amount. Engineers generate, no, I didn't say that. So there's only so much processing power, and there's a lot of tasks coming at it. And like any computer, if there's too many tasks, one of the software components hangs, doesn't it? Don't want that. We'll talk about that a little bit more in a minute. But the computer takes on board, it's basically got 5 input systems, hasn't it? Yeah, what you hear, frequencies, noise, but also lower frequencies that you more feel as well. Sight, what you see, just looking at light reflection, taking it on board. Then you've also got the systems of taste, and you've got smell, and you've got touch. Obviously, when you're driving, the 2 that assist with your driving are the top 2. The distractions can be the others, potentially, as well as distraction and all the others. So we're really thinking about and doing research to really understand how the human brain works, but how the human reacts to distractions, because that's the quest of making things safer. So if you look at it, look at the physiology and look at cognitive load. We're absolutely obsessed about cognitive load and this concept there's only so much the brain can do. We actually got a team doing some really cool research looking at if you give simple tasks to do while you're driving through a city centre versus driving on an open road at a steady state. I actually found simple tasks of just searching for something, yeah? Maybe just changing radio stations and just simple searching tasks. The data that we pulled together is you're over a third, in fact 40% was the data that we pulled, more likely to get the task wrong when you drive through a city. That's really quite worrying because there's lots of people in cities, children, kids, bikes, kids are children, bikes, people, all of those things in cities, and it's really, really important that we think about their safety. So that's a real key factor. Then the other thought, travel sickness. I really suffer badly from travel sickness. In fact, hands up who suffers from travel sickness. So there's a few in the room. So one of the key bits of research that we're doing, and you might want to keep your hands up and then we'll see who modifies their view, that there's 2 things with travel sickness. Firstly, lots of people don't admit it. But there's actually research that's coming together out there to actually show that your level of IQ is directly proportional to your sensitivity of travel sickness. Yeah? If you have a low IQ, you're less likely to be travel sick. Anybody not get travel sickness? It's a really, really important factor, yeah? It's good, that one, isn't it? Usually when you do that, you get a different vote the second time, funnily enough. True fact, though, isn't it? Interesting. Wonder why that is. We'll talk about that another time. So we focus on travel sickness because you're spending time in the car. And remember this fact that lots of people don't say they're feeling sick, but they're really suffering. But when you're feeling sick, the cognitive load is way up there, yeah? When you're being travel sick, you can't barely, when you're being travel sick in the car, what's the first thing you said when someone speaks to you? Shut up and leave me alone, yeah? That's generally what they say because they're absolutely up there with it. So how can they utilise the time in the car to do other things? How can they actually get value in the car? So we're doing a lot of research to look at how do you actually make the environment in the car as a passenger, how do you make that environment less susceptible? It's basic things like space, be able to see the horizons, visibility, large moon roofs, yeah? There's a big roof on the eyeplace, there's a clue, yeah? All of those things actually help the perception, yeah? Whenever I'm being driven in the car, I actually find, and it probably is psychosomatic, but doesn't matter, because reality is, if it's a perception for you, it is a reality. If the big roof's open and you sat and you can see out, you don't feel as sick. It's just a fact. So we're thinking about all those details inside the vehicle to actually make it look at the low frequency. You've been on a boat? When you go on a boat and you go along the shore and you get that gentle rocking, very, very low frequency is terrible for travel sickness. So again, we're looking at the ride on our new vehicles. And you'll actually see the new vehicles that we're launching, some of them very soon. You'll see that we've dramatically reduced the spring stiffness, but then we're controlling the system through the damping system. But in order to manage those reaction forces, we're making the bodies an order of magnitude stiffer, because obviously you've got to take the loads and you've got to have durability and make sure that you pass fatigue, so the stiffness and strength has to be increased. So we're thinking about all of those technologies because ultimately, how you're making it better, how you're actually making time, how you're making it a safer experience to be in. Other technologies, really cool concept the research guys came up with, looking at what you'd want to do when you're off-road. When you're off-road, one of the challenges is being able to see everything where you are, be able to see around. So they created a technology called the see-through bonnet, created a camera system that as you drive along underneath the car, it's tracking the data all of the time, and you can actually see completely where you are, whether you're in the ruts, whatever you're doing off-road. But this is also really relevant in the urban jungle. If you want to make sure you park close to the curb, if you want to make sure that you don't drive over your kid's push bike or anything else that's there, how can you make sure that you see things? How do you make sure you don't damage the wheels? How can you see where you're going? How can you get through tight spaces? This sort of technology will come very, very soon in Jaguar Landrover products. Very, very soon, in fact. So all of this technology is coming. One of the other things then, V2X. The car is becoming the device. The world is becoming fully connected. It's obvious that engineers need to maximize the capability, and effectively think of the 5 senses that the brain can take on. They unfortunately can't see round corners. You can't see what's coming over the hill. You can't see the car in front. You can't see the young child in front of the car in front. All of those things. So by thinking about how you actually connect the car, not only to other cars, but how do you connect it to other devices, you really, really can make things better, safer, and cleaner. You really, really can. Simple things like, if you're driving along, and you can quite easily calculate that if you know in 300 yards, 300 metres, show me age, 300 metres, the traffic lights are going to be red by the time you get there. You could actually alter the speed of the car. You could lift off very, very slightly. Yeah, the car could automatically lift off. You could slow down a little bit. And it means actually, by the time you get to the traffic lights, they turn green. That'd be awesome, wouldn't it? Yeah, makes you much calmer. Cognitive load definitely helps, but it's also good because you use less energy. All of that technology is capable of communicating. You can also make sure that as you're approaching a junction, you can know whether there's anything coming. So you could adjust your speed accordingly, just like the traffic lights. All of these things make it safer. You can connect all the cars together. You can understand that 2 cars in front, 3 cars in front, they're braking very harshly. Yeah, on motorways, how often do you get cars shunt up between each other because first one panics, brakes really hard, second one didn't quite wake up quick enough, hits that one and then pile all the way through. You could actually make sure that you predict that. One of the key things in traffic in terms of getting more flow is keeping a laminar flow. Yeah, if you can keep all of the cars going at a very steady state velocity, you can actually get more cars through, you can make it more convenient. V2X is really coming, really excited about the technology that brings and the opportunity it brings and how much fuel, energy you can save, but also how much safer you can actually make it. Then also things about your ability to drive. We talked about the human brain, this cognitive load. A couple have a bit less anyway, and a bit more. There's a bit of a variation. There's a distribution, yeah? But one of the key challenges is when you're tired. When you're tired, it goes down dramatically. There's an order of magnitude reduction if you start being tired that you just don't concentrate properly. You don't actually remember what's happening. You know, as a thought, how often have you driven a journey that you do regularly? You get there and you suddenly think, or you're on the way and you suddenly think, where am I? You can't remember it, can you? Because your brain's thinking about other things. It can be really dangerous if you don't quite concentrate properly. If you also then think about when you get a bit of road rage, the processing power of the brain gets taken up by other things. We're doing research looking into that. We've tried things like saying, warning, you appear to be angry. Doesn't tend to help very much. Doesn't tend to make it any better. But if you think about various light, various colours of light, frequencies of light, can change that perception, can actually help calm a little bit, maybe music. Yeah? So we're looking at all of those things that you can actually have to influence, to actually think about trying to calm people down a little bit, and thinking about all those driver aids that actually come. But also thinking about how, you know, facial recognition technologies, cameras and such like, that technology is there and all of that can come. Some of the same technology that's actually going to look at traffic signs and be part of the autonomous technology as well. The brain's actually very good at detecting these things. However, it does make mistakes. That's the real challenge with a brain and a human person. It's also interesting if you watch humans, and we do studies on how they behave, humans always keep on taking risks, some more than others. Yeah, keep on taking risks, and often they take it too far. That's why you need all these safety aids, just to pull them back, gently steer them every now and again from taking those risks. Because once humans have done something, oh, I got away with it that time, I'll have another go. That is unfortunately how the human brain works. So these technologies can really, really help that. Autonomous. Lots of debates about autonomous. The one thing that is absolutely undebatable is it makes people's lives better. Please have a look at what we're doing.
Today we're here to show our level 4 prototype vehicle off to some of the Invictus Games competitors to see and get their initial reaction to a level 4 autonomous vehicle.
Driverless autonomous cars is just a really exciting technology. As a visually impaired person, I lost the ability to drive when I lost my sight. This technology that's been developed by Jaguar Landrover is just going to give me that ability to be independent.
And the thought that this can take people with blindness, illnesses or anything like that back into mobility, back to getting back on the road is huge. It's huge. And I know little things are creeping in, we have cruise control in our cars, auto parking, but to think that something might actually drive our cars one day blows my mind that I can't believe we're there. I can't believe we're even close to doing that.
It was a great experience. I open my mind for the future. It's a possibility to feel freedom, not to drive it. Bring me at home alone. You don't need the help. I think that is the right way for the future.
Having both my arms significantly disabled, being unable to drive wherever I wanted, do whatever I wanted, was one of the biggest factors which stopped me being independent. So being able to get back in a car that was adapted to me unlocked the world again.
It is amazing how far technology has come.
If I can drive again with the help of a piece of technology, that's just a positive thing, do you know what I mean? And this is going to be fantastic that, when that technology comes, it's going to be a real step forward for me as a visually impaired person.
Last year, August, I was medically discharged from the military for my back, and it was a very daunting time. But through Help for Heroes with Mission Motorsport, who introduced me to Jaguar Landrover, and at that point, they knew my limitations, and they've really supported me. And now, even with the games, the way they support me, and like I said, even in my day-to-day life, if I have struggles, there is stuff put in place to help me. So it's been amazing.
Cool, isn't it? The passion in those people. They've been through absolutely incredible things. That Invictus passion, honestly, you can't help but, when you spend time with these guys, get an absolute lump in your throat. It really, really is amazing. And the thought of engineers helping people, giving their freedom back, it's just amazing, isn't it? I mean, I think of my father. He can just drive at the minute. He's 79. The thought of him losing his mobility is absolutely terrifying, absolutely terrifying. And the thought, if I could send a vehicle to get him and bring him back, that would be absolutely amazing. So autonomous technology is going to come, absolutely going to come. It's going to be an incredible challenge. Legislating it's going to be an incredible challenge. But on that journey, there's a host of safety aids that are going to come. And we've got to embrace those safety aids and find more innovative ways to make it safer. It really, really, really can come. The difference for the elderly and everybody. But also, think of if you're blind as well. You can actually go and find a car can come to you, you can get in it. So those opportunities are huge. Now, if that doesn't motivate you as an engineer, then I don't know what will. It certainly motivates me, and it's really exciting. So, smarter. Engineers definitely want to be smarter, don't they? Don't they? Yeah, okay, just checking. Thought you'd nodded off. Definitely want to be smarter. That's one of the cool things that engineers have really, really, really got to obsess about. And there's so much we can be smarter about. Zero congestion has got to be an obsession, hasn't it? If you think, I came up to London today, lucky enough to come up in a car, work for a car company. Traffic was pretty good actually, so no problem at all. But data says that some surveys done, some studies done in London, the average Londoner spends 100 hours a year stationary in traffic. Probably a bit frustrating. You don't suffer from travel sickness when you're stationary generally, that's probably the only positive. But there's a real opportunity, isn't it, to utilise that time. There's a real opportunity to smooth that. Talked about some of the technologies to actually smooth the traffic flow. But there's a huge opportunity to actually get smarter and actually create convenience. If you think about what is the biggest challenge these days, the phrase money rich, time poor has actually become quite an accepted phrase, hasn't it? The reality is, older guys like me years ago in the 60s, yes, in the 60s when I was born, there wasn't probably the same level of wealth. There wasn't the same level of basic income and everything that you had. Generally, and unfortunately there's still many, many people in the world, but here in the UK, generally, people have got enough money to put food on the table. And some of the surveys that are done now versus maybe the 80s, one of the things that motivates consumers more than anything is actually buying a device that saves time, genuinely saves time. Yeah, not just early adopters that buy a gadget for doing anything that they play with on Christmas Day evening, and then by Boxing Day it's no good and thrown in the cupboard. But genuine devices that are going to make your life better is one of the number one things. It always feels like there's not enough time. And if you come back to the cognitive load piece, how many people, when they're stressed, say they can't sleep? And when they're stressed, they can't sleep, they haven't got enough time to sleep, so they get more stressed and they're even more stressed. Time is definitely the most important thing. And really, how much time have you got to relax and do things? That is, people will want to make life better. They want to make more time. And that is really an engineer's duty to find ways of making more time. And also, with respect to time, I watched a film a few years ago, and I find this concept fascinating. I'm not a Hollywood buff, by the way, and if you watch this film, don't watch it and say, oh my goodness, he's lost it. But the concept of this film, yeah, with Justin and Amanda, I think it was, were the two actors. The concept of this film was that actually the currency of life is time. And the concept of it, I found it fascinating, and I think it's, a few years on, I think there's so many truths of how this film fits with, unfortunately, how society is today. The concept of the film is that you're born, you live till you're 25, everyone lives till they're 25, but then once you're 25, doesn't really matter the age in terms of the thought, once you're 25, a counter on your arm starts, and you're given X amount of time, I can't remember how much it is. And obviously every minute that you live, that time goes down, or every second that you live, that time goes down. But if you want to buy some food, the time goes down. If you want to buy some medication, the time goes down. And then you have to go to work to earn more time. Also, the other concept in the film is that lots of people in a privileged area have infinite time, but the masses don't. And time really is that currency. And if you think about time is life, how long people actually live, that is actually the concept of the film. That's what engineers have really got to focus on. How are you going to recognise that actually the true currency is actually time, and how well you can actually use that time? That was an interesting thought. And we share that internally as a concept to think about how can you actually make people's lives better? How can you add to the value of that currency of time? Because that's more important. You then think about time-saving techniques using a smart world that we live in. We've made sure the new Jaguar I-Pace has got learning skills. If I go and get in the car, it knows who I am because it knows I've got the key, it knows I've got the phone. As I open the door, it'll adjust the seat exactly how I had it last time, how I like it. It will put the radio station or music player, whatever I've got, the device put on exactly the same as I had last time. It will set the air conditioning to exactly the temperatures that I like. And I can set off in the car. Really, really simple, basic things. But it saves a little bit of time. It makes life easier, and you really like it. And it's actually quite cool when you open the door and the seat goes back into the position as you get in. It's quite cool as well. But those things simply save time, and it's completely connected. And we're working on how we basically keep your profile in the cloud, how we understand every single piece of data of how you like to set the car up, and making sure that if you get into a second Jaguar Landrover product, it'll set everything for you again. Those are technologies that maybe you wouldn't naturally think about, but they actually save time and they make life better and really, really create this passion to actually have more time to enjoy, which is the most important things. So these technologies, these learning technologies, are actually going to come into the vehicle and actually buy people more time. That is absolutely coming. Also then, you think about being smart and think about sharing, and think about what we need to do. We're really excited at the new battery electric vehicle that we've got of I-Pace, the world's first premium SUV. We're really proud of it, you might have noticed that. But what was really, really cool, and yes, engineers are competitive, is in Munich, we actually got the first rank of taxis working. Don't know if you've heard of a car company based in Munich, one of those mainstream German ones. Yeah, pretty cool to see those when you get at the airport, isn't it? Yeah, I quite like that. Spend a little bit of time in Munich, really, really cool. And the data that we're getting off those cars is absolutely fascinating. We're learning things that when the chauffeurs first have the cars, they're obsessed about plugging it in. It doesn't take them many days, but they just actually back off. The range anxiety and the desire to keep on plugging the car in absolutely backs off. Really, really, you just watch this curve of how they actually just get used to it. Yeah, and they just plug it in when they need it. They know what mileage they're going to do. They know what range they've got, and they relax. We're also understanding how the vehicles move, all sorts of data that we're collecting. A fantastic piece of work and really cool that we're doing it there, right on the back door of another car company. We're also being really, really smart and actually getting with quite disruptive technology companies. So Waymo is a company set up, part of the Alphabet Group, which is owned by a company, I'm not sure if you've heard of it, called Google. Yeah, technology company, really awesome. And these guys have set a division up under Alphabet to actually provide full autonomous transportation out in the Bay, in the States initially. We, with them, in a shared economy, working together, within a couple of years, we'll have a few thousand of the Jaguar I-Paces, fully autonomous, running around the Bay, making people's lives better, having a taxi 24/7 that are fully reliable because a computer is driving all of this. That is true sharing. We are embracing the fact that people want to share cars. We are embracing that fact and just finding a way of making it better, but partnering with key technology companies. That's the key bit engineers have to be able to share. So, in summary, autonomous, safety aids, driving safety, it's going to come. It's an engineer's dream to be doing that sort of thing. It really is. It's so cool. The traditional mechanical engineer to be involved in some of these things really, really is awesome. The breadth is fantastic. Yeah, there is never, ever going to be a dull moment. Connected. The world is connected. You can't stop progress. Yeah, you might try. You can try and turn your phone off occasionally. But the world is connected and the car has to become the device. It is coming. Electrification. There's full battery electric vehicles. There's plug-in hybrid vehicles, but there's also using electrification technologies to make the internal combustion engines even better. And the shared economy, as I mentioned, there's lots of disruptive technologies in the shared economy. Some of those guys, some of the companies, they're absolutely changing the world. Airbnb is actually the largest provider of hotel rooms than anyone else now. You'd never have thought that didn't even exist a few years ago. Yeah, you talk to most people, they wouldn't dream of using a normal hotel. And it's all about sharing your house, flexibility. It's good for the environment, isn't it? Bit of a challenge for a hotel company, but it's good for the environment. Really is a good thing to do. Shared economy is absolutely coming, and engineers have to drive that. So, in summary, the challenge we're embracing, the challenge I'd give to every engineer in the room, it's our duty to create a world with zero pollution, zero accidents, and zero congestion. Simply, either be a disruptor or be disrupted. Thank you.
Nick, thank you very much indeed. Truly fascinating. I never cease learning from you, so thank you very much. We have some questions, not least for me, as I'm a journalist, but some members of our audience have submitted some questions earlier on.
I don't know which worries me both.
Are you okay?
Which worries me most?
Do you mind if I drive? I'm dreadful with travel sickness. Yeah. It must be something to do with my intelligence. Possibly not. But just a bit of insight into Nick. You say you've worked at Jaguar Landrover for 35 years.
My 35th year.
Your 35th year. Not a long time. We're the same age. I'll let you work out which one's older later on. But you joined, in football parlance, you joined your home club and you're a one-club player. And you really live and breathe the brands that you work for, so much so that what I'd like you to do now, first of all, is just give us a bit of insight into your garage at home, if you could.
I've got things in my garage that I love. All sorts of things, all sorts of tools and such like. I love to get my hands dirty all the time. Probably get fingerprints on things as well. Love trying to mend things. Doesn't always work, but try to. Other things I got in the garage, and Steve's asking about the cars, probably one of my favourites is I am lucky enough that a few years ago a friend helped me find a very early 1948 Land Rover. Land Rover was first created in 1948. And to go out and drive in that car is, it's really, really back to the roots, it's really basic. But one of the coolest things is actually trying to find something on it that hasn't actually got a function. You can't find anything that hasn't got a function. But also, I think, when you drive it, you actually feel the spirit of the Wilks brothers. You feel what those guys were doing straight after the war. It absolutely comes out, and I really do get quite excited about it. So that is a key thing that's in the garage that probably don't drive enough.
It's not just the Land Rover, though, is it? There's a few more things.
Yeah. There's, lucky enough, got an XK. Not a 48, unfortunately. It's a later one. But again, absolutely same spirit that's in that, and that back to basics feeling. Has got disc brakes on the front though.
Good, that's a relief.
I fitted those, but it's a really, really cool car, because I really believe when you drive any car, and Steve drives more than I do, I'm sure, but you can actually feel the passion in the teams when you drive a car. I really, really think you can when you maybe drive one of the more mainstream brands that comes from part of Europe. You can feel it. But when you hopefully drive our cars, I think you can feel some of the spirit and some of the passion that's in the engineers. If you drive an I-Pace, I really think you can feel it.
And more modern cars?
Modern cars, got a very early Range Rover, which again, absolute admiration, not only the Wilks brothers and Charles Spencer King. Lucky enough to meet him a couple of times. He was actually a relation of the Wilks brothers, and he had this incredible drive to take all the capability and off-road capability of the Land Rover, which became renowned as the vehicle that was seen everywhere across the globe. And in the late 60s, he created the Range Rover. Mm-hmm. And his simple vision was make it do everything a Land Rover can do and make it do everything that a Rover can do. And he created the merge of these two cars, and that's really what the vehicle was. And probably the fondest moment I've got of a Range Rover is I grew up in a little farm just outside Oxford, and there used to be a show in Silverstone, not in Silverstone, up in just up by Coventry. I've come to me in a minute, and Royal Showground. And I remember stood there with Stoneleigh. That's right. Well done. Hey, good question. And I remember being stood there with my father. I could have been no more than 3 or 4, 2 or 3 maybe, maybe 3 or 4 actually. And just when it was launched, and I remember my father talking about this vehicle, about that is the coolest vehicle ever, and how fantastic it was, and his dream was to own one. So to join Jaguar Landrover was an absolute honour.
And your everyday car now is an electric car, unsurprisingly, the I-Pace.
Lucky enough, everyday car. I'm lucky enough that actually I have a Range Rover Sport, which is fantastic car, company car, of course, which gasoline, which I'm an engineer, so it's in the blood. Yeah, love it. Can't beat a petrol supercharger. And then an I-Pace, which is just, well, it's electric. Yeah, the other one, okay.
That's not a bad. That's not a bad selection of cars.
No, it's just brilliant. It really, really is. It's an absolute honour to work in the car industry, and it's fantastic to have these products. It's always really cool when you go out in a new car and you stop somewhere and people are coming up and looking and taking photographs. And lucky enough to be in places in an I-Pace and people are stopping and photographing it. It really is exciting.
It must be really difficult when that day comes through and you've got to choose your next company car. But,
thinking
about some of those older cars that you've got, particularly the Landy, for example, how do cars like that inspire the work when you think about reinterpreting some of the engineering from those cars in today's cars? I know there are lots of rumours of a new Defender on the horizon. You know, looking back, what are the links?
It's not a rumour, there's going to be one.
Oh, there's a scoop, ladies and gentlemen.
Well, I think, some of your guys got the scoop with someone driving one, didn't they?
Oops.
Anyway, can't talk about that. Lost my train of thought. So the real focus on all of the Jaguar Landrover vehicles, we're lucky enough that we've got a fantastic owner, genuinely, and the support that we get to create the right character in our cars is something we get incredibly support to do. And we're lucky enough that we've had the investment and the support to do that and really expand the company. But there's a little bit of spirit in there that, you know, some of the things that we do, you know, if I remember working on the concept of the new Range Rover, and we were adamant that you'd have almost 2 feet of suspension travel. I think if maybe you were in Munich or Stuttgart and you said you wanted 2 feet of suspension travel and you wanted wheels that are, you know, nearly 800 millimeters in diameter, they might say, that's not possible. Yeah. But that's the sort of thing that we do and create that incredible capability. And that passion and drive you get from the old vehicles. And it's all about making something that you're really, really going to remember. And work in the automotive industry, there's nothing cooler than when you travel around the world and you see these cars out in the world. And you see them and you think of all the monies that are coming back in to give people jobs in the UK. That's really incredible. But you also think about how those cars have changed people's lives, the stories and the things that they're having. You're like, I'm sure you watch car karaoke.
Yeah, I'm aware of it.
Not sure of it. It's a TV show in the States. I don't actually watch it. Well, I do occasionally because the car they've chosen is a Range Rover. How cool's that?
Very cool.
Very cool. Okay.
Yeah.
You didn't really agree, did they?
Some of the people that have been in the passenger seat, pretty cool as well. Now, taking you back 34, 35 years, when you first started out, your remit today is pretty broad. Back then it was all about metal and oil, basically. Today it's about software and electronics. Is that fair? How have you managed to overcome that, and has it been a good thing and an opportunity?
It's a fantastic opportunity. The key thing with engineers is to be curious and to be challenged. And when I started, I was a body engineer, actually. It wasn't the profession that I chose, body engineering, so I worked in body engineering, NVH, noise, vibration, harshness, crash and such like, was how I started. I actually wanted to be an electrical engineer, and that was always my desire. Studied electronics at school and was always fascinated by computers. Remember the ZX81?
I do, the Sync there, yeah. Of course, he went on to build one of the most fantastic vehicles ever made.
Yes.
I don't think everyone agrees.
But that was pioneering, wasn't it?
It was.
That was some real spirit, and he gave it a go.
Before its time, I think.
You really got to admire him. Batteries was a key challenge. But the challenge I had is that when I did the colour blindness test, I was colourblind. I sort of knew that already. So I was actually told from a very early age that I couldn't be an electrical engineer. That was always a bit of a passion. The electrical engineers I work are over the moon that I'm now an electrical engineer. They love every minute of it. But seriously, learning about software and working on software and looking at mechatronics, basically every system in the car has got some sort of mechatronics control system now. And the passion for doing that. And one of the thoughts is that as Jaguar Landrover's grown, it's fantastic the speed that we've grown and the amount of engineers that we've got now here in the UK. We've actually been taking on between 500 and 600 graduates and apprentices every year for the last few years in Jaguar Landrover. So the quantity of Gen Y or just above Gen Y that we've got that basically don't remember anything other than the internet, and they don't remember anything without a connected world. That is what they live in. All of that comes really naturally to them. And it's really, really fantastic to see the youngsters, don't mean that negatively, the younger people compared to older people like me, seeing those guys embracing that technology. But what is also really, really good to see is traditional mechanical engineers that may be experts on engines, gearboxes or body or other technologies. They're actually very, very familiar with computational techniques. And, you know, everything is modelled now. Everything that's mechanical in the car, you're absolutely predicting it, and you're growing the IP and making sure that the simulation tools, computational tools, and then rigs are really, really predicting the outcome. That skill set is very, very portable. And it's been really exciting that we've been running a training program in JLR for all the management. There's a training program that we set up with some of the engineers that we actually ran as a first line team, myself and all of the team, to really make sure that all of the new technologies we really understand. So every manager's crashed some code. Every manager's looked at some circuits design and foolproof circuit design and actually done tests to understand what's wrong with it, actually understood system engineering. We're also retraining on the mechanical skills as well. And it's been really exciting to see actually how quickly curious engineers take all that on. So yes, there's a big change to mechatronics and software, but it's actually really, really exciting. And engineers take to it naturally.
Something else that's changed dramatically for you over the years is ownership. Jaguar Landrover's been through a lot of highs and, should we say, some more challenging times. Ford, BMW, Honda, you talk very affectionately about your German colleagues. There's a degree of competition in there. But what particularly with the likes of Honda and BMW, what have you learned from those guys? What do they bring to engineering that we don't?
It's been a fascinating time, and you can learn so much from each and every culture. Ford, not sure, John Deere, I want to get the right name in a minute, Honda. John Deere's an aspiration for me as well. Honda actually had a 20% share in Rover for quite a few years, and we worked with the Japanese. Their ability to be organised and structured, their ability to work together was absolutely amazing. Found that in BMW, and I've got ultimate respect, seriously, for all the other brands. But the key thing that you really, really notice is that there's something in the spirit in the UK, and there's definitely something in the spirit inside Jaguar Landrover, that engineers want to do the unthinkable. They tend to be slightly less organised, unfortunately. That's the character trait that we tend to have. But that ability to find ways of doing new things, the innovations that I took you through, that is really the edge. And that is really the edge that we've got to leverage, because change is the new norm. Whether you like it or not, you can't stop progress. And that, I think, is the real edge that we've really, really got to harvest, and we've got to push, because engineering in the UK is the most important, one of the most important, I think, to the health, livelihoods and everything here in the UK.
Are we getting there? Are we adopting that change?
I think there's a focus. We could absolutely, definitely do more. I don't think you can do too much. There has been a bit of a focus not to care so much about engineering, but I really, really, really believe, and hopefully preaching to the converted, that has got to be something that every engineering leader has got to push. That's absolutely something we've got to encourage. And we've got to get rid of the perception that engineers just have dirty fingers. It's got to be something that you want to do and create that desire. And you can see with the young grads and apprentices that we're bringing in, the diversity of them is awesome. And if you think about every single startup across the globe, the ones that really do disruption, they have a fantastic mix of youngsters that got a very, very different view. Yeah, and if you want to find out the truth, if you want to find something out, you ask a youngster or a drunk. I'm suggesting the youngsters will be very, very honest. Yeah, drunks aren't so good apparently. So the youngsters are very, very honest, and you see that challenge with the older boys and girls that have actually stuck in their ways a little bit. That is perfect, and we can do far more of that in the UK. And there's many other industries that are doing some fantastic work in the UK as well. It's not just automotive, and I'm not just saying that.
Okay. I want to get some questions that have come from the audience, some quick-fire ones for you here. We spoke about ACEs, autonomous, connected, electrified, shared. Just briefly, autonomous, is anybody really asking for it?
Of course. You saw in the film. It's going to make people's lives better. Of course it's going to come. But I think we've got to think of it as a journey of driver aid to make driving, make vehicles, make transportation safer. So absolutely, it has to come. Obviously, there's lots of worries about full autonomy. How do you be absolutely certain? Because people are using artificial intelligence and computer learning to actually train vehicles to be autonomous. You've obviously got the last end of the curve, right down at the end there. All those use cases only happen occasionally. How do you make sure that you really test and really legislate? Because an fully autonomous car can make life a lot safer. Of course it can. But it's really, really impossible to understand how you would come to terms with the fact that that system could actually kill somebody. They might kill significantly less. But we've got to work out as an industry and as a group of engineers how we actually really make it foolproof. So I really do. People are driving it, and I talked about active cruise control. Yep. I cannot imagine life without it. Yeah. And it's such a safety aid. So I really believe so. I think people want to control the car as well. Yeah. When you drive and you see lots of other films, they like to take over as well, don't they, every now and again? Yeah. I think.
Connected, cybersecurity is a very real issue. What are you guys doing about it?
Cybersecurity, again, has to be another obsession. As the car is fully connected, as the car has every system is a mechatronic system, so therefore you can access it. That is a key focus. We've got some really, really cool guys that do some fantastic work to make our cars secure. And we've also got an incredible track record that our cars are basically impossible to steal. But unfortunately, what happens is, and for many other brands, people break into houses and actually steal their keys and use that as a way of actually getting hold of the vehicles. But we've got a fantastic success rate that the control system that we got, the telematics, we can actually pinpoint the cars, and we've been incredibly successful in getting a few cars back.
Okay, electrification, what are the big barriers?
Convenience and cost. Everything, talked about it, every engineer, if you want anything to be truly disruptive, it's a simple ratio of convenience and cost. Biggest challenge is batteries are incredibly expensive. The systems are incredibly expensive. Battery electric vehicles are a fantastic vehicle, but there is a premium. And making sure there's the infrastructure to charge. We've also got to make sure that you get the full benefit if there's green energy as well. So making sure that that really happens and making sure there's the right policies and right initiatives to do it.
Shared, let's talk about the S. Isn't shared going to be a bit of a problem for you? People are sharing cars rather than buying individual cars?
It's definitely an opportunity. You've got to look at how you can use what you've got with the car to share it. How could you find ways of actually encouraging people to buy a car that they readily share? I mentioned Airbnb. One of the key things that's happened with Airbnb is actually lots of people are buying a property, but then they're using the fact that they lend it out to people every now and again and get an additional income to actually have a house. So actually you think about it in that philosophy, it's an opportunity.
I like the way you spun that. We'll make a journalist out of you yet. Okay. So some more questions from the audience. Len Pannett said, how are governments adapting to the needs for strategic changes from revamping generation and distribution of power to modernising legislation? We had to talk about governments at some stage.
Yeah, I thought we agreed we were going to talk about
We're not going to mention the B word now.
Well, as I mentioned, it's a huge challenge. Unfortunately, if you look at, mention Germany again, if you look at Germany, a third of the energy is renewable. Here in the UK, we've really got to pursue that. You know, we are on an island. There's lots of wind and there's lots of sea. Surely there's an opportunity. Not quite so much sun as maybe further down south. We've really got to focus on how we do that, and I would do anything to support any policies that any governments, any incentives that we can do, because what can be better than having your own windmill or whatever and creating your own energy? It's all about being sustainable. So, you know, it's a key challenge for governments to wrestle with, but I think we've got to push it.
Dr. Alan Stevens from the University of Southampton asks, the charging time for EVs will likely be several tens of minutes. Will this limit the acceptability and uptake for those who need to charge on the street? And what can be done about it?
I think it comes back to the other two questions that we mentioned is you've got to have the infrastructure to charge cars. You've got to understand how much energy you need available. Actually charging the car, if you can do it overnight and you've got somewhere to park it, actually covers most of your usages. I mean, there's lots of data that if you look at car usages, average journeys, range anxiety is not as much of a problem as people think it is. But you do need somewhere to charge overnight. If you can pull 7.5 kilowatts overnight, you can actually get quite a lot of energy in. Obviously 7.5 kilowatts now, if you've got 10 hours overnight, you can get 75 kilowatts in, which is pretty usable amount of energy to get, you know, well over 350, 380, depending on the range kilometres of the car. But the key challenge is making sure that's available, making sure there's somewhere to park and actually charge up. But also then, those longer journeys, we've got to get an infrastructure across the country. And I think that's a huge challenge to do all that, because rapid charging is definitely needed when you're on that summer holiday, winter holiday, or just long trip when you need a greater range. So definitely needs governments to support that.
Okay, here's an interesting one for you from Anthony Bond. We've got the tech currently to limit speeds, which will have similar benefits to full autonomy, but we don't do it, presumably because of human adoption issues and privacy concerns. Does this give the same concerns and the same issues that could be a hindrance to the rollout of full autonomy?
Data regulation is obviously a key challenge, and we've got to be really mindful, and quite rightly, that you protect people's data and you don't make that freely available. But there are ways of autonomizing, of making the car anonymous and actually controlling speeds. I mean, that sort of thing, of course it will come. It's just the simple use of V2X technology, and why wouldn't you? And you could think of it as a driver aid anyway, so why not? If it makes people's lives better, it's got to be the right thing to do.
Okay. Vikesh Radgama says, do you see there being a future with regards to connectivity where it become mandatory to put the car into automatic mode, such as when driving in the city or on the motorway, to reduce human error and allow more cars on the streets too?
I think as we talked about, yes, because these technologies will drive things to be safer. It's a driver aid and it's a support. So why not? If it makes life better, those are technologies that are definitely going to come, and quite rightly so.
Here's one of my favourites from Mirdad Kamali. Says, if disruption is good, why didn't established automotive companies pick up on the electric revolution when the idea was introduced by Sir Clive Sinclair or the Think car from Norway?
We're the first premium SUV.
That's your answer?
Yeah.
Talking about
it's seriously, it's about a point in time where the development costs are huge. The technology's got to be mature enough to deliver a product that's really, really worthy. And genuinely, we are really excited that we're the first premium SUV, and we were really, really obsessed about making sure all the capability of cars have today, you can wade in 0.5 metre of water in a Jaguar I-Pace as well. Really, really cool thing to do. So we've made sure that all of the things that you can do in a car in one of our vehicles today, you can absolutely do in a Jaguar I-Pace. So we're really excited that we've done it, and I'm quite excited that we beat some of the German competition.
So talking about disruption, last night I spoke at a Tesla Owners Club meeting, and one of their hot topics was your car. They were very, very complimentary about your car.
Thank you.
So what's the engineer's view of Tesla?
It's always important for engineers to admire what others have done, look at what they've done, and find a way of making it better.
Perfect answer. So we'll move on quickly from that one then. Who's next through the disruption door? Is it someone like Dyson?
Who knows?
But you'll look at what they'll do and try and do it better.
I don't know. I mean, I always think it's you have to have an eye on the competition, but you've also got to look at yourself. What else can you do? How else can you drive yourself? You've got to keep an eye on the competition, of course. And I've got ultimate respect for anybody that pushes the technology forward, because that is actually what an engineer is all about. And that is definitely inside me. So if we can learn from some of the others and we can actually create a segment and keep a marketplace, we're up for it.
Okay, last couple of questions, because I sense we have a thirsty audience and there are drinks outside. So Ken Hattersley asks, how would autonomous vehicles respond to pothole avoidance? Can they detect and real-time dodge wheel-damaging road defects? And similarly, how would two vehicles resolve a conflict if they're on a single-track road in opposing directions?
Goodness gracious. There's some incredible challenges there. Predicting damaged road surfaces, absolutely, and it's something that we look at. We're looking at suspension systems that can predict inputs before they happen. I think in this case, you're referring to actually damage. There's no reason why you can't be scanning the road and understanding these things that are coming before you. So absolutely, yes. Two vehicles going a single track road. As I said, there's a distribution, there's a tail end of use cases for autonomous vehicles that will certainly be an inventive challenge.
Final question for you. As an engineer, you must work in similar way to journalists who always spot the missing apostrophes everywhere. You must look at other engineering solutions and criticise some secretly in your mind, but admire some. So which, whether in the automotive space or elsewhere, are there any engineering solutions that you think, wow, that's clever?
I think always in medical science. When you see some of the techniques and some of the things that are developed for keyhole surgery and such like, that is really, really cool. So doing things like that is really, really fantastic. And then some of the simplicity of some of the devices that you can get, you know, it's actually fantastic that I can communicate back to my home. I can see what's going on. You can answer the doorbell when you aren't there. You can take a delivery. So some of those things, they're really quite exciting as well. But medical science, definitely.
All about stuff that makes life better, I guess.
Exactly. Engineer's duty, I've heard.
Okay. Well, on that note, I shall draw things to a close. But ladies and gentlemen, I think you'd like to join me in thanking one of the most talented and youngest-looking engineers in the world, Mr. Nick Rogers.
Thank you. Thank you very much. Thank you. Oh, okay.
So, as well as thanking Nick, it's my duty to inform you that the next EngTalk is on the 18th of February, and there are the details up there, and we hope you'll be back here in time for that. Most importantly, right now, there are drinks and a technology showcase out in the registration area, and Nick, I understand, will also be in the bar. Try and keep him away for a little while, but for now, it's been an absolute pleasure. Thank you all very much indeed, and have a good evening.
Thank you.
Thank you.